Hello everyone. So I'm going to take you through the process of using SPSS to model and simulate the relationship between life expectancy and socioeconomic factors based on the life expectancy WHO dataset. As seen below is our SPSS. First of all, I imported the dataset, and to do this, I imported the dataset from Cargo into SPSS for analysis. Then I downloaded the dataset from Cargo's life expectancy dataset. And in SPSS, I select File, Open, then Data. I navigated to the location of the file in CSV and opened the file. I then verified the dataset was properly imported by checking the variable names and ensuring they matched the dataset columns. Then next thing I did was data cleaning. For data cleaning, it was very crucial to eliminate any inconsistencies or missing data which could distort our results. I went to analyze, then descriptive statistics frequencies to check for missing values across the variables. I observed that several columns such as GDP and immunization rates had missing values. And for handling this missing data, I used SPSS's replace missing values function. For some variables like GDP, I chose the mean imputation method to fill in the gaps with the average values, and for the category variables, I chose to leave them as it was. Additionally, I checked for outliers using box plots and removed extreme outliers, particularly for variables like GDP and mortality rates, to prevent them from skewing the model. And then the next thing was exploratory data analysis. And by this, before performing regression analysis, I conducted exploratory data analysis to understand the relationships that were between life expectancy and the socioeconomic factors. To do this, I used graphs, Lego, dialogues, scatter to create scatter plots of life expectancy against factors like GDP, adult mortality, and immunization rates. The scatter plots showed a positive correlation between life expectancy and GDP, and a negative correlation with adult mortality. And these findings justified the choice of variables for further modeling. The next thing was the multiple linear regression analysis. To quantify the relationship between life expectancy and the socio-economic factors, I conducted a multiple linear regression analysis. I went to analyze, then regression, linear in SPSS. I set life expectancy as the dependent variable and selected the following independent variables, which are GDP, adult mortality, immunization rates for both DPT and hepatitis B, literacy, then the literacy rate. Then I clicked OK to run the regression analysis. Then the R-squared value indicated the proportion of variance in life expectancy. Explained by the socioeconomic factors. A higher R-squared value, like it gives 0.85, suggested that these factors strongly influence life expectancy. Then the coefficient table showed that the GDP had a positive coefficient, meaning a higher GDP was associated with longer life expectancy. And adult mortality had a negative coefficient, meaning higher mortality rates were associated with shorter life expectancy. And for the immunization rates, had positive coefficients, meaning higher vaccination coverage improved life expectancy. And the p-values for each factor were examined to ensure significance. For example, GDP and adult mortality, which had p-values well below 0.05, indicated they are significant predictors. And for simulating changes in socioeconomic factors, to simulate the effect of changes in socioeconomic factors on life expectancy, I created a hypothetical scenarios by adjusting the independent variables. And in scenario 1, there was increase in GDP. I used SPSS's compute variable function to stimulate a 10% increase in GDP across all countries. And in scenario 2, there was decrease in adult mortality. And similarly, as I computed a 20% reduction in adult mortality rates, I then used the coefficients from the regression model to estimate how the changes would impact life expectancy. And in the simulated results, in scenario 1, where GDP increased by 10%, the model predicted a 2-year increase in life expectancy for countries with lower GDP values. And in scenario 2, reducing adult mortality by 20% resulted in a significant increase in life expectancy by about 3 to 4 years in some regions. These simulations demonstrated the sensitivity of life expectancy to changes in economic and health indicators, supporting the idea that the investment in healthcare and economic growth can significantly improve longevity. And in conclusion, according to the findings summary, these are our findings summary. The regression analysis confirmed that GDP, adult mortality, and immunization rates are significant predictors of life expectancy. And in conclusion, the simulation models further highlighted that even moderate improvements in these factors can lead to substantial gains in life expectancy. And the actionable insights are policymakers can focus on boosting GDP through economic development and reducing mortality by improving healthcare systems. And the importance of increasing immunization coverage was also emphasized, as it directly contributes to a healthier population and higher life expectancy. For the final recommendation, based on these findings, I recommended countries prioritize economic growth, improve healthcare, and promote vaccination programs to achieve longer life expectancy. And the model's results provide a constitutive basis for these strategies.